Hello, and welcome to my presentation on the aquaculture of polychaete worms. Let's just get right into it. So, as aquaculture becomes more and more popular and widespread in the U.S., intensive farming practices are going to become more common. And with these new techniques is going to come more government regulation. And these government regulations are going to look at things like the economic impact of these farms. And one way that they're going to monitor this is by the quality of the effluent wastewater from these farms. So as a farmer, you're going to think to yourself, how am I going to comply with these government regulations while also minimizing costs? And one way that I think is going to be a really effective method for this is using polychaete-assisted sand filters. What is that? Well, we're going to get into it, but first we're going to talk about just the basic biology of polychaete worms. So polychaete worms are a species of marine annelid, and they are distributed throughout every ocean, living in a wide variety of niches. So on your left, you see ragworms, Hedisti diversicolor, and they're a species of polychaete worms, common in the intertidal zones in the North Atlantic. So they live in brackish or marine water. And you might have seen them crawling around on the ground when you're digging for clams. They have a generalist diet. They're happy to feed on everything from phytoplankton, diatoms, bacteria, detritus, small invertebrates. Basically, what they do is they dig in a little burrow, and then they will kind of writhe their body to suck in seawater, and then they'll, eat whatever they can get their hands on that comes in with that seawater. They usually get to be about 4 inches long. These are pretty good sized ones, and these were harvested for a recreational fishing bait. And another interesting fact is that they're model species for experiments. Anyway, so getting back to polychaete-assisted sand filters. What is a polychaete-assisted sand filter? Well, really, it's just a sand filter that's populated by a certain species of polychaete worms. And basically, the worms, their job is to live in that sand, and the water that they get is usually filled with organic matter, and they will eat that organic matter and convert it. Instead of letting it go out as effluent, it's converted to worm biomass. And polychaete-assisted sand filters have a variety of applications. Obviously in aquaculture, like I'm saying, but also potentially municipal wastewater. And moving along. So here is an example of a polychaete sand filter. I just took this. This is an image from an article, Performance of Polychaete-Assisted Sand Filters under Contrasting Nutrient Loads in an Integrated Multi-Trophic Aquaculture. So it basically just shows the experimental setup of this, where you have a culture of Sparus aurata, or gilt-head bream. It's a species common in the Mediterranean. So they're an intensive, semi-intensive earth pond culture. And they have it split up into 3 things. On the far left, you see raw water was fed directly into a polychaete sand filter. Next, the raw water was fed through a drum filter, mechanical filtration, and then through the worms. Last, it was passed through a drum filter, then a biofilter populated with Ulva rigida, sea lettuce, also common in our area. And then it was sent through the worms. And then the effluent was sent to a settlement pond, and it not recirculated, it's just left in the settlement pond. And basically, the first 2, the raw water and the drum filtered sand filters, were actually able to produce a secondary culture of worms with no additional inputs. They actually were able to create a net gain. And the third one, probably due to the fact that it was, most of the, organic matter was filtered out, there was not a significant amount of growth. So to wrap it up, I should say that polyheat-assisted sand filters could have a lot of different advantages over traditional mechanical or chemical filtration systems. Firstly, they could be less expensive. Basically, they're just a bin with sand and worms in it, and that's nothing to it. And secondly, if you're able to culture a secondary population of worms, you can, harvest that. You might not be able to sell it to people, but you can grind it up and use it for fish meal to offset your food costs for your primary crop, which could be a pretty advantageous characteristic of these filters. Anyhow, here are my sources. If you have any questions, I'm probably going to be sitting in the middle front row and just let them rip.